Hey everyone, I'm Professor Gellért. You may know me from my other instructional videos. Here I am with my students, Jeremy, Bobby, and my dog, Schwab. Enjoy the video.
The professor gave me salt A.
I got salt B.
I'm going to add 5 tablespoons of salt to the beaker and find out what happens.
Doing the same with salt B.
Oh my, this flask is cold.
Whoa, this one's hot!
Let's ask our professor why that is.
Right, you have 2 salts, and one of them causes endothermic, and the other causes the exothermic reaction. Let's see which one's which.
When my ammonium nitrite was dissolved in the water, the system absorbed the heat from the surrounding, making the flask feel cold.
Yes, that's a perfect example of an endothermic reaction. Here, let me show you how it's done. Alright, yeah, so the endothermic reaction can be represented with the following equation, which is very simple. It's NH4 and NO3 plus you add change Marcus's, you add heat, and the result is change Marcus again. Water, which should equal NH4 plus aqueous plus NO3 minus aqueous.
Ah yes, I can see that heat is observed in this reaction, making the flask feel cold.
Very good. Now, based on this reaction, can you think of any other examples of endothermic reactions?
What about photosynthesis, the process used by plants and other organisms to convert light energy into chemical energy?
Let's look at
that B1?
yes. Let's look at the photosynthesis reaction and dig deep.
Okay, so here we're gonna explain what an endothermic reaction is like, and I'm gonna talk about the hydrogen iodide. So here you have like the equation, and it's like 2 H2I2, and it ends with 2 Hi, and the change in the hydrogen here is 21 kilojoules, and that's like the important number right now. And here it's like where we actually do the equation, and like our givens are going to be the 25 grams of the 2H1 produced, that we're like, it's the number that we're choosing to use for the equation, the change in, that it's here, the 21, and what we need to find out is how many kilojoules were absorbed in the equation, and like after the reaction. So here like we have that's 2 of the moles, because we end up with 2, so we have to like do the calculation, and 1 mole is going to be 129.912 grams per mole. And like here we do the equation, so we just have to do a regular mole reaction, and it's like the 25 with the mole to cancel it out, and like the 129, you put the other H1 here, HI, so you can cancel it out, and you end up with this. That's like the end of the reaction, and like it says here in the need, the energy would be absorbed, and it makes that, and that makes it endothermic reaction.
And when my plasma chloride dissolved into water, the system released heat into the surroundings, making the flask feel hot.
Yes, that is an exothermic reaction. Let me explain. Minor inconvenience. So, alright, yes. So, like on the other reaction, we can explain the reaction very similar. plus. Oh, here's a test. Do you remember what comes after this equation?
Heat.
Close, but no, it's actually plus 2 HCl, and then we have the heat.
Yes, I see that in this case. Heat is released in the reaction, which elevates the temperature of the mixture, making the flask feel hot.
Based on that definition, can you think of any other exothermic reactions?
Combustion.
Yes, very good. Combustion is the burning of carbon-containing compounds, such as oxygen, from the air that produces carbon dioxide. Water belongs to heat. The combustion of methane, or CH4, is a well-known example. It can be represented with the following equation. We need more space. Let's say we're looking at the following equation. CH1 plus 2O2 equals CO2 plus 2 H2 plus heat. Explanation math thing.
So now I'm going to try to explain the exothermic reaction and how they work. So first, it's basically the equation, a chemical reaction in which the energy is released. Here we have an example, and basically how it works is that, like here for the hydrogen and the chlorine, like here it shows that like the energy needed to release them. I'm showing it with this, and it's the same with the sodium and the OH. And basically how this works is that it has like the energy really needed to separate each element from the compound is more than what is needed to separate the salt and the water. And like it just shows you how like the energy here is being released to this part, and it would be like that in a reaction.
I learned so much today.
Yes, a lot.
You're welcome. You know, if you're watching this, actually Professor Gellért also. I was stripped of my license and my PhD. If anybody knows, can please contact Stanford or Yale University. Oh shit, I heard they're coming.